start recording. Innocent. Innocent, you can record. Good. So, as I was saying that this is correlation analysis. Sometimes we're interested in finding out whether advertising, does advertising increase on our side done under what we call correlation and regression analysis. So the strength of the relationship is given by the correlation coefficient that ranges between -1 and +1, -1 and +1. Such a change may either be an increase or decrease in one variable that is followed by also an increase in the other variables. For example, an increase in sales promotions may bring about an increase in the volume of sales, which will then imply that sales promotions and volumes are correlated or they are related. So if sales, if an increase in sales promotion leads to an increase in sales, that means that they have a positive relationship. The sign of the correlation coefficient indicates the direction. If it is positive, then they move in the same direction. That implies that a change in one will also increase a change in the other. If it is negative, then it implies that they move in different directions. So an increase in one will lead to a decrease in the other. So a negative correlation implies that the change in the variable is in the opposite direction. So in a nutshell, that is correlation analysis, and that is the introduction, where we're going to be calculating, where we're going to be looking at diagrams to see whether there's a relationship between two variables. Scatter diagram. Like we've done in the previous notes where we looked at our organization, we drew the different diagrams like histograms, like ogives. We also have visual display when it comes to correlation. This is another visual display of data. It shows the association between two variables acting continuously on the same. Scatter diagram illustrates the strength of the correlation between the two variables through the slope of a line. Scatter diagrams make the relationship between two continuous variables stand out visually on the page in a way that raw data cannot. Scatter diagrams may be used in examining the cause and effect relationship between the variable, that is continuous measurements. So scatter diagram, a good example. Assuming I want to get a graphical representation of the relationship between QT marks, QT revision sessions, and the actual marks obtained. I take time to compile this data, and we have. The most important thing is for you to assess what depends on the other, because we have two variables. We have what we call the dependent variable, and we have what we call the independent variable. So the most important thing is for you to identify what is the dependent variable and what is the independent variable. What is the dependent variable and what is the independent variable? So from this, what depends on the other? We have number of sessions and QT marks. What depends on the other? What depends on the other? You have to type what depends on the other. I'm waiting for the what depends on the other. Marks depend on the number of sessions. So the dependent variable is normally associated with y, and the independent variable is normally associated with x. So if we say that marks depend on that, so we shall have that marks are y, and then the number of sessions are x. The number of sessions are x. So the dependent variable is normally associated by the y. Let me make this one bold and that. So the dependent variable is normally associated by y, and the independent variable is normally associated by x. So again, the dependent variable is normally on the vertical axis. Vertical axis, that is where we have the dependent variable, vertical axis. Whereas the independent variable is normally on the horizontal axis, horizontal. Horizontal axis. So that is why if you see that diagram, we have the marks on the vertical axis, then we have the number of sessions on the horizontal axis, and then we have it all plotted. We have it all plotted. Then we have this line, So this one will show you that marks are positively related to the number of the number of revision sessions. So the more you revise, the better marks you get. The more you revise, the better marks you get. You can even see from the data that the person who had 7 sessions scored 88, and the person who had only 1 session scored 29%. So the more sessions you have, the better marks you have, all factors constants. So that is what we call the visual representation, as long as you know that the dependent variable is on the vertical axis and the independent variable is on the horizontal axis. So since most of the scatter points are lying on the estimated regression line, we can use this scatter diagram to estimate, say, QE max when a student attends 20 revisions. Scatter diagrams show the relationship, but do not prove that one variable causes the other. So that is how we present it visually. That is how we present it visually. We plot that and that. We plot that and that. So you'll have 1 and 29. 1 and 29 is there. Then you'll have 3 and 44. 3 and 44 is plotted there. And after that, we draw a smooth line between these two, between the observations. If you find out that you cannot draw this, the straight line, then it implies that there's no relationship. That is, they are scattered. So we can either draw it sloping, that is from right to left like it is, or it can slope from left to right. If it slopes from left to right, then it shows that there's a negative relationship. There's a negative relationship. Clear? Any questions before I continue? Good. Pearson's or product moment correlation coefficients. The Pearson correlation, if all points on the scatter diagram lie very close to the straight line, then there is a strong relationship between X and Y than when they are scattered away from the line. To measure the strength of the direction of correlation or relationship between X and Y, we utilize the coefficient of correlation, popularly called the Pearson or product correlation coefficients. So that is a formula, and that formula is not very difficult. If you begin with the, for example, the numerator, it is n, where n are the total number of observation. Then xy is a product of both x and y. Then you split the sums. So you'll have summation of x and summation of y. Then you find the square roots. You find the square root of the product of these, of x and y, where you'll have the summation of x squared. And this is, you subtract off the sum of x. You'll have the summation of y squared, and you subtract off the sum of y. So that is the formula. That is the formula. That is the formula. We go to an example. We'll look at an example. We'll look at an example. Good. The table below shows the monthly advertising expenditure in $1,000 US and the corresponding sales revenue in thousands of Mercy Limited for the last 8 months. So we have the months from Jan up to August. Then we have advertising expenditure and sales. So what depends on the other? What depends on the other? What depends on the other? What is X? What is Y? So you type, tell me that this is X, this is Y. Type quickly. So sales is X, and Y are adds. Okay, so we have sales are X, and Y are the advertising expenditure. Now, once you have this, the rest becomes simple. So you have from Jan up to February. So we have X and Y. Let us begin the calculations. Let us begin the calculations. So the first thing is to get the products. And what is the first product? Quickly, give me the first product of X and Y. Hey, don't sleep, don't sleep, don't sleep. Give me the first product of X and Y. $420, good. $420, good. Next product. But those are correct. Correct. 1-1. Herbert, that is correct. Next product. Freddy Kajubi Rumbuye. You have a name. Fred. Happy, that is correct. Gift, that is correct. Kajubi, are those your real names of Sivagara, that is correct. Okay. Lumbuye and Fred Kajubi. Happy, those answers are correct. Happy, that answer is not correct, Happy. Check. Even that one is not correct. The last one is 875. Correct, 875. Add up everything in that column. Add up everything in that column. Add up everything in that column. That is correct, Kayamba, that is correct. So get x squared, Kajubi, that is correct. I hope others are also contributing. While you're waiting for my answers, you may burn in hell if you're still waiting for my answers. 2, 2, 5, not 6. Those are correct. Continue next, quickly. If 900 is correct. Next. That answer is correct. Quickly get the other. We train speed accuracy. Kajubi, that answer is correct. Next. Afi, that answer is correct. Gordon, welcome on board. Kajubi, okay, in the right track. Kayemba, that answer is correct. Lumbi, that answer is correct. And members who are participating are the ones who will pass. Don't think things if you don't participate, you think things are normal, you are just enjoying my lecture. Add up everything in that column. That answer is correct. Add up everything in that column. Angel, welcome on board. Innocent, hey, you participate. The more you're active, these things are easy to pass. But if you think you are enjoying the lecture and you think things will be easy, gift, that answer is correct. 6697. Quickly go to y squared. Go to y squared. Elliot, good. Y squared, Sevagala. Is that y squared? 784. Angel, that answer is correct. Jingo, Aisha, welcome on board. YYE. Yeah, well, that is welcome. Innocent, that answer is correct. Yeah, Fachi. Okay, that answer is correct. Sevagala. Yeah, Fachi, that answer is correct. Happy, that answer is correct. Next. Good. 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 So those answers are correct. Good. Add up everything in that column. Add up everything in that column. Innocent, that answer is correct. Reina Matov, that answer is correct. Add up everything in that column. And you that promise you have not even contributed anything and you're talking about copy. Kayemba, that answer is correct. Medrin, Arinda, welcome on board. Elliot, that answer is correct. Add everything in the first column as well. Add summation of X and summation of Y. The first and second column, Chividige Christopher. Now Jolie, good. Add. Who is Elliot? You give us answers. You're not supposed to communicate anything apart from answers. Rina. Midrin, that answer is correct. Add the first sum of x. X is equal to 221. But you must be using an iPhone. Very good. Next. Add y. That is for y, add for x. I mean, that is for x, add for y. $499. Good. Okay, let me now share my values. Let me share my values. Okay. Not again, though. Just a minute. Mm-hmm. Good. So we get R. We calculate R. We calculate R. And if I go here, put inserts. Put my fractions. Our n was what? If you count n, how many observations do we have? Our n is equal to what? N is equal to 8. Let me first increase on the font. N is equal to 8, so you'll have 8 dots. Our summation of product xy, summation of xy is equal to what? Summation of xy is equal to what? Hey, don't sleep. Give me the answer. Summation of xy. We have 8, 6, 3, 3. Minus summation of y. Summation of y. Summation of x or y. Hey, don't leave. Summation of y. 293 times summation of x. 221. Over the numerator, I put the square root sign. I put the square root sign and brackets, because we're going to be dealing with 2. So shall have our first n, which is 8. 8. What is the summation of x squared? What is the summation of x squared? Ephraim, you've been lost the first time you're contributing. Summation of x squared, 6697 minus summation of this is you find the square of what? Of 221. 221, that is all squared. Now, good. So we put brackets again. 8 times summation of what is the summation of y squared? Summation of y squared is 11267 minus minus 293, and that is squared. 293, and that is squared. So we insert our, and we break it down. I increase on the fonts to 16. Decide, enter that. So what are we getting? 8 times 8633. What do we get when we multiply this? What do we get when we multiply that? Quickly, quickly, quickly. Alex, you just have to type. We get 69064 minus. What do we get when we multiply this? When we multiply that, Yemfachi is telling us 64753. 64753. We go denominator, add that fraction again. What do we get when we multiply 8 by that and subtract off the square? Eight. What do we get for x? Just get for x here. 8 times that, then you subtract off the square. We get 4735 times. How about for y? For y, 4287. 4287. So we go to the last step. I press insert. I bring my that. So what do we get from the numerator? From the numerator, 69064 minus 64. You get 4311. And what are we getting when you multiply that and you get the square root? When you multiply this and get its square root, when you multiply that and you get its square root, so you'll get 4505.44. So what is the final value for R? R is equal to what? So R is equal to 0.95, 0.9576 pass. So we can see that it is positive and strong. It is positive, strong advertising expenditures, you'll have an increase in sales. I think It was Juliet, that person was the one who's recording today. Herbert. Should be Herbert. Should be Herbert. So you have to talk to Herbert very well. You know he's in control. Juliet. He's in control. Okay, we go to rank coefficients. Rank coefficients. It is there in the group. You see, the advantages of online is that even if you miss a lecture, you should inbox me. But it's already in the group. Herbert, I think, shared. So the rank coefficient. Previously, we've expressed both X and Y in a numerical form. However, there are situations where we are unable to express the variables in numerical form in order to carry out correlation analysis, but we have enough information to rank these variables from first to third. So sometimes we cannot measure, sometimes we only have to rank. Here we employ the Spearman's rank correlation coefficient method to compute the correlation coefficient expressed in numerical form include efficiency, honesty, intelligence of employees. Sometimes you just have to use ranks. You cannot measure, because you cannot measure intelligence, you cannot measure honesty. So the correlation coefficient computed in this measure, so that is the formula. The formula is R1 6 minus D squared, 6 minus D squared, where D squared is the differences in the ranks, N is the number of observation, and that's all. So we look at an example. Two interviewers in KPMG separately gave the following points to 12 candidates who had applied for the post of chief accountant in L&B using the Spearman's rank correlation coefficients. Do you think both interviewers have similar opinions on the candidates? So we have interviewers, leave the part B, leave it. So we have interviewers from A up to L. Interviewer 1 and interviewer 2. And these are the marks they appointed from 30 up to 57. Then from 30 up to, so we are supposed to rank, and we can either rank in ascending order or descending order. We can either rank in ascending order or descending order. So let me know if you're on that page so that we can begin ranking. Give me a yes if you're on that page, if you have those values in. Give me a yes. Good. So we begin ranking. We begin with the smallest. So looking at the interviewer 1, what is the smallest value there? So Sevagal is saying 19. So we have 19, 1. So we put a 1 there. Next is what? Next is what? 30, but 30s are many. 30s are many. 30s are many. There are 4. So what we shall do, Sevagala, you're first, but we don't know how we've got into that bit. So we need to let other people know. So what we are going to do is find the different, how we get to 3.5. You're right, but how do we get to 3.5? Let me go to home. Oh, sorry. Home, increase. So the first 30 will occupy the second position. The second 30 will occupy the third position. The fourth 30 will occupy, the first will occupy the second. The second 30 will occupy the third position. The third 30 will occupy the fourth position. And then the last 30 will occupy the fifth position. So you'll add them and divide by 4. You'll add them and divide by 4. So you'll have 2 plus 3 plus 4 plus 5, divide that by 4, and you get 3.5. You get 3.5. You get 3.5. Is it clear? So you are going to go where we have 30, and in each 30 you'll put 3.5. You have a 3.5 there, and you'll have a 3.5. Not clear, Tracy. There are 4 30s. There are 4 30s. So remember, we've already given out position number 1. The first one will take the second position. The second one will take the third position. The third one will take the fourth position. And the fifth one will take the, and the fourth one will take the fifth position. So you just put their positions and get the average. So after getting the average, you'll get 3.5. So you'll go back to where we have 30 and you'll put 3.5. 3.5. 3.5. Where's the other 30? So we have 1, 2, 3, and another 3.5. 3.5. Hey, Trace, is it clear? I've only seen you when you're saying it is not clear, but you have not been contributing. So we go to the next one. The next one, since we've stopped on the fifth, the next one will go to number 6. Angel, that is good. So 32 will go to 7. Remember, you are going to rank from your 32 will go to 7. What is next there? 35 will go to 8. 35 will go to 8. What is next? 40. 40 will go to 9. 40 will go to 9. What is next? 46. 46, there are 2. So what position do I put? You get the average. What is the average? 10.5, 10.5, 10.5, and 10.5, 10.5. And the last one is 7, and we put 12. We put 12. Great. So just give me the ranks for R2. You rank R2, and you'll give me the final ranks. I'm giving you okay, we work together because you waste a lot of time. The first one is 1. Next. 20, we have 2. Next. 21, we have 3. Next. So I got you a computer. Next. 23, there are 2, so you'll have 4.5. 4.5. That is 23, 4.5. Next. 30, what should I put? You give me the value as well. Don't tell me, Lily. You give me 30, I put what? Next is 26. 26. There are 2. So you put 6 and 6. Next.
We can have fun.
Okay, and Agatha, I don't trust your answers. How can you say that is 7? Next. 26 is 6.5. 6.5. 6.5. 30 is 9. 30 is 9. 30 is 9. 30 is 9. 32 is 11. And this is 12. Good. So we find the difference. We find the difference of the ranks. So we'll have 3.5 minus 9. The first one you'll have 3.5 minus 9. Good. That cannot be 9.5, Chris. Awerimba. You are wrong. Maria, that is correct. You get the differences. Jingo, welcome aboard. That answer is correct. Chirabo, that answer is correct. So you get the differences. So get the differences. After getting the differences, you get the squares. After getting the squares, I just need you to give me the sum of the squares. I just need you to give me the sum of the squares. That is the sum, the last column. The sum, the last column. Oh.
$88.
Hey. That is correct. That is correct. That is correct. So let me share my answers. Let me share my answers. Jingo, that answer is wrong. It is 127. That answer is wrong. You people, that is how we're going to fail simple things like this. One 127. So we calculate R. We calculate R. So we shall have R is equal to 1 minus, so you'll have 6 times 127 over, there are 12, so you'll have 12 brackets, 12 squared, 12 squared minus 1. So get for me the value of R. Get for me the value of R. uh, 5, 5, 6. So the question was, do they have the same opinion? Yes, they have the same opinion because it is positive. They have the same opinion because it is positive. They have the same opinion because it is positive. Though, but both interviewers have the same opinion because the question was, do they have the same opinion? Since it is moving the same direction, as in we've gotten a positive answer, we can say that they have the same opinion. They have the same opinion. They have the same opinion. They have the same opinion of determination. The coefficient of determination. Now, this refers to the amount of variation about or accounted for by changes in the independent variable. So sometimes you may be interested in getting to know how much of the changes are being brought about by the independent variable. And that only applies to the first example. That only applies to the first example. So we go back to the first example where we had the dependent and independent. So get for me R squared. So square this value here. Get for me R squared. Get for me R squared. Square that value. Get for me R squared R squared is equal to what? R squared is equal to 0.9159. So multiply that by 100. Multiply that by 100. So you have 91.5. 91.5%. 91.5%. So how do we explain that? Remember, we had two variables. We had advert expenditure and sales. We had two variables. We had AD sales, AD expenditure, and we had the sales. So we can say that to get the percentage, by multiplying by 100, we get the percentage. That is why my answer has the percentage sign. So we can say that 91.5% changes in sales are explained by or attributed by attributed or caused by attributed would be attributed to advert expenditure, AD expenditure. Of course, there may be some other factors that contribute to increase in sales, and those are the ones that are responsible. So you can just get like 100 minus that. So you could say that 91.5% changes in sales are attributed to advert expenditure. 91, they're not sales. R squared does not measure sales. They are not sales. R squared or R do not have units, but when you multiply by 100, it becomes percentage. It becomes percentage. Good. We look at the last topic. That is correlation as regression analysis. We look at the last topic, which is regression analysis, and it is similar. That should take us in the next 10 to 15 minutes. It should be done. 10, 15, to which two variables X and Y are linearly related, but does not tell us how to find a particular straight line that presents the relationship. The problem of establishing which particular line best fits the point of the scatter diagram comes under the heading linear regression analysis. Thus, regression is the statistical method which measures the average relationship between two or more variables and then helps us to estimate or predict the unknown value of one variable from the known values or values of the related variables. E.g., the marketing manager can find the average relationship between money spent on adverts and sales revenue made, and then be able to estimate the level of sales at a given advertising budget. The actual estimation is done by using a rule which specifies the estimate of one variable when given the value of the other variable. It is important. The manager has to identify which variable depends on the other so as to distinguish between the dependent and independent variable. This we've already done. The independent variable is also known as the regressor or the predictor or the explanatory variable, while the dependent variable is also known as the regressed or the explained variable. So these are other names. You read the importances. We go to the calculations, and we are going to be interested in calculating two, that is B and X, B and A, B and A, B and A. So that's the formula. Or I can redo the formulas here. I can redo the formulas here. I can redo the formulas here. Let me just put, for formula B, let me insert that. I put, you'll have N times summation of XY. It has the same numerator as coefficient. The only thing that changes is the denominator. Times summation of X, and summation of Y. Let me just increase and make it bold. Then the denominator deals with only X, so you don't need the square root. Denominator deals with only X, so you don't need the square roots. So it will be summation of X, but these are X squared. The X squared and minus that whole thing is all squared. So that's the formula for beta. That is the formula for beta. Beta whereas for A, you just get the sum. You just get the A is equal to summation of Y. Let's put fractions. Summation of Y over N. Now subtract B times, put fractions again, summation of X over N. So there's an example there. Nile Brewers believes that a large budget for the television advertisements will create a large demand for its beer. Fit a line of best fit to the data given below and predict the number of crates sold when the company injects in 500 millions in advertisements. So you have, you need to know what depends on the other. Crates depend on advertisement. So advertisement is X and the crates sold are Y. So you'll have that and that. So tell me if you're at that level. Tell me if you're at that level, that we can continue. It was supposed to be there. A. Here we have an N, sorry. You're right, here we have an N. Thank you for the observation. We have an N. The N is there. The N is there, Michael. So quickly, and we've been explaining that ever since we started. I don't know where you've been. You look at the recordings. Quickly get me X and Y. Get me the products. Get me the products. What depends on the other? I don't know what English you want me to use. Depending that for something to increase, you need something depends on the other. I don't know if there's another word that I can use to make it easier. That is purely English, Angel, purely. I depend on you. So if I depend on you, I am Y and you are X. Good. Get me X squared, because we just need X squared. And add everything. Good. I don't know how best I can explain that thing of dependence. Unless I thought I would add, that is because that is purely English. And that is correct, that is correct. Get the values as well. Others are just waiting. You get the values. Add everything, add everything, add everything in all columns. Rubbish. So those are your answers. Those are your answers when you add. These are your answers when you add everything. So we calculate B together. We calculate B together. Calculate B and give me the value of B. Follow the formula. I'm waiting for B. Which is B? Gorina, you're just tired. I don't know, what did you have for lunch? Cassava. What is N? So you'll have 8 times 119,350 minus 920 times 885 over 8 times 124,500 minus 920 and 920 squared minus so get me B. Madam Rina, now you know what B is. Beta. Mark, is that correct? Huh? $0.9625. So get me A. A is equal to 885 over 8 minus 0.9625 times 920 over 8. Quickly get me A and we complete members. These answers were wrong. 2.64 members. So this is how we complete, and Afi. I don't know where you're getting yours from, but we all have that. So you need to go and check. You can't all be wrong. So without any advertising expense, so when this value is 0 here, when that value is 0, without any, well, I don't know what you people have calculated. Ajira, do you just type? I'm putting the values that you put here. I don't even calculation here, you're getting wrong things. 8 times that. Interchanged what? X and Y. Oh, sorry. Sorry. Oh, 920. This should have been 885. Should have been 885. But the rest remains. Oh, wait, doesn't, no. What was our X here? X advertising, X. So this is supposed to be X. Gerard, this is X and this is Y. This is X, this is Y. So advertisements, credits are Y. Of that. So 920. That's that. So this here of 920. So those who follow like sheep, you're in trouble. So you have 8 times that. This one remains because we got X squareds were that. So you'll have, this one will change to, 8, 8, 5. This one will be times 9. Happy today, you're correct. Oh, did they cheat? So give me the final answer. What? Is it 2 point what? The difference is the similarity. The difference is minimum. 2.64. So without adverse expenditure, if this value is 0, the credit sold will be 2.64. Now, if we need to, if you need to predict, Elliot, they tell you to predict where you have adverse expenditure, you just put that value. For example, they told us, and the unit change in this will have been, this answer is wrong, will be 0.93, 0.939. So if you want to predict, you just multiply that by 500. You just multiply. If you've spent 500,000, you just multiply that. So you multiply and get me the answer. So what are we getting here? I don't know why you're getting different answers. This should have been 0.939 beta. And here we have 0.939, 0.939, 0.939, 0.939. So finally, are we done? So those who are recording, you can stop recording. Innocent and they can stop recording.